Okay, good morning, everybody. Just a quick reminder first, make sure to always check your CASA calendars because I guess this is a pretty busy week for you because there are a lot of things to be submitted. I guess you have a couple of quizzes and then you have a popper and then you also have the practice test and you have the actual test one due this weekend, if I'm not mistaken. So kindly go to your CASA calendars to check those deadlines. And okay. Yeah, as well as I also think you also have you started with the poppers in the lecture. So that was also due earlier. So yeah, it's a pretty busy opening week for you guys. So yeah. But anyway, you don't have any choice, so you should have started doing that. Also, let me know if you also have some questions about that. So yeah, you can send it to via the chat so I can see it right away. Um, because I guess 7.1 is a little bit easy. It's more of just only one topic, mean value theorem, and there's just a limited number of questions or forms of questions that we can answer in that. So I'll be happy to answer some of your questions about the previous homeworks or ongoing quizzes and so on. Yes, all sessions are recorded. You can watch them via MS Teams, or you can also watch it via my website. So I have a website or a web page for this class. It's on the top tab of the live meetings channel. So I list them. I list all of them there, all of the materials for this class. But if you want to use MS Teams exclusively, then you can retrace the post in the channel. Okay. So, all right, let's start so that we can answer more questions for today. Again, send your questions in the chat. So if you want to discuss some of the problems there, right? So let me begin with some of the remaining questions that you have or that some of you might have from worksheet number 1 and some related topics, which is basically use substitution. So I start here with problem F. Remember my numbering here. This is carried over from worksheet number 1. So I'm using letters for questions that are not part of the worksheet I prepared last time. But essentially, let's do this. Problem F. We are given the function capital F to be the integral from x to 0 of the square root of t squared plus 9 dt, and we want to calculate f double prime of x. So again, the first step here is to solve for f prime. Okay. And f prime is nothing but the derivative of the function f, right? So f prime is the derivative with respect to x of the given function capital F, which is the integral from x to 0 of t squared plus 9 dt. Okay. Unfortunately, so here I want to apply the fundamental theorem of calculus. But if you remember from last time, we reviewed the fundamental theorem of calculus, and taking the derivative of this integral function requires the lower bound to be a constant and the upper bound to be the variable x. Yeah, you're right, Robert. The goal is to find the derivative, but the problem here is the function f given here has an integral. So if I'm looking for f prime, I'll be dealing with this form, right? The derivative with respect to x of an integral function. And the only way we can solve this is via the fundamental theorem of calculus, right? But again, f dt requires the lower bound to be a constant, the upper bound to be the variable, right? So I need to interchange the order of integration here. But remember, interchanging the order of integration comes with a cost of a negative sign, right? So instead of the integral from x to 0, I'll be computing the integral from 0 to x. But take note of the negative sign introduced there because of that reversal of order. And oops. And this would be the square root of t squared plus 9 dt. And I want this form because the fundamental theorem tells me that, oh, okay, now your lower bound is a constant. The upper bound is a variable now, which is the same as the variable of differentiation. So what will remain would be the integrand, the function inside the integral, but evaluated at the upper bound variable. So the upper bound variable is x, so the answer is x squared plus 9, right? That's the fundamental theorem of calculus. But for this particular problem, we were told to find f double prime of x. So I need to take the derivative of f prime once more to get f double prime. But basically, you can look at f prime to be negative of x squared plus 9 to the 1/2. So its derivative would be negative 1/2 x squared plus 9 to the negative 1/2. Then chain rule kicks in. You have an extra 2x over there. So then you can simplify your answer and have it as negative x over square root of x squared plus 9. And that's our final answer. Okay, so that's f double prime of x. All right. Any questions on that? This was sent to me via email. I just forgot to send this, but hopefully he or she is present in the class today. So is that good? All right, so let's try another one. Problem G. This is another problem sent to me via chat. So here we need to find, so you're given an equation, this one, which relates little f to cosine x, and we need to determine f prime of pi over 2. So the goal here is to take the derivative of f and then plug in pi over 2. But unfortunately, we don't know how f looks like. All we know that f is inside that integral over there. But the thing here is I need to solve for f. So how can I get rid of the integral so I can free f up? Any idea? I don't know if we have answered a similar problem to this last time, or was that my other lab class? But how do I get rid of the integral symbol there? I want to get rid of the integral symbol so that I can free little f up. Okay, Katia is correct. I take the derivative of both sides. So if I take the derivative of both sides, it will look like this. Yeah. Okay, and then here I will use the fundamental theorem of calculus. Lower bound is a constant, upper bound is the variable of differentiation. They all matches up. So that will just be f of x plus 5x, right? What remains would be the integrand, but evaluated at the upper variable, right? Equals the derivative of cosine is negative sine x. Okay, and then I solve for f, so that means f of x will be equal to negative 5x minus sine x. And remember, we're looking for f prime evaluated at pi over 2. So I take the derivative first of f, so it's going to be negative 5 minus cosine x. And finally, I can plug in pi over 2. Because again, the problem asks us to determine the value of f prime of pi over 2. So that means it's going to be negative 5 minus cosine of pi over 2. But what is cosine of pi over 2? Cosine of pi over 2 is 0. So this will just be negative 5. All good?
Yeah, that makes sense to me.
Mm-hmm. Okay, let me just browse the chat. I guess there's a couple of questions sent. I guess my meeting chat froze, so hold on. That's weird. I cannot browse through the chat in my laptop, but hold on. Let me see in my tablet. But you guys are still hearing me, right? I hope I'm not cut off.
Yeah, I can still hear you. I'm not sure.
We can still hear you.
Mm-hmm. Okay. I received lots of questions here. Question number 6. I guess, did we answer question number 6 last time? I guess we covered this last time. Is that correct? Or was it in my other class? That's one thing. I have a couple of lab classes, so I'm not sure which ones were already tackled. Yeah, we answered a similar one, I guess. So let me just double check so that we won't spend too much time with those problems. Let me see. Oh, we did not answer this. I guess this is in one of my CASA tutoring sessions. So yeah, so let's try this one. This is a bit interesting. Okay. Let me just add a couple of pages here. Okay, then take a screenshot of this. Okay, so why can't I get the screenshot anyway? So for that particular problem, that's odd. I can't take a screenshot. So 1 over square root of x at x equals 16. Okay, good. So let me just double check this. Sorry guys, my MS Teams on my laptop is acting weird. So I cannot work with dual monitors, but hopefully this will. Okay, yeah, there you go. So let's go call this problem H. Okay. So for problems, for this problem, we need to find A and B, given that the function y equals a over root x plus b root x has a minimum or has a minimum value of 8 at x equals 16. Okay. So, all right. So for this one, we'll need to work on, again, the key in problem solving is that first you identify what are the given information and translate those given information into a mathematical sentence that will lead you to the answer to your problem, right? So here we need to find the values of A and B. Yeah, you can do that. Yeah, Rohil's suggestion is correct. I can do that. He's suggesting to plug in 16 for X and 8 for Y, because I guess that's one of the info in the problem. So the problem says that we will get a minimum value of 8 when X is equal to 16. So using that info, I will have 8 equals A over root 16 plus B root 16. And that would be 8 equals 1/4 A plus 4B, right? And of course, you all hate working with fractions, so I'll just multiply both sides by 4. So I'll get 32 equals A plus 16B. Okay, so I have this equation. Let's call this equation star. But unfortunately, we cannot find A and B using only this equation. We have two unknowns A and B, but only one equation, equation star. So we need to look for another information or to look for another equation. And the crucial information coming from the problem is that the function just doesn't have a value 8 at x equals 16, but that value 8 is a minimum value. And I guess that's where Marin's suggestion in the chat will kick in. She suggested that you have a minimum value, therefore 16 must be a critical number, right? So maybe I should write that down since x equals 16 gives a minimum. So it's a critical number. I hope you guys still remember this. It's a bit working backwards because remember, when we're looking for the maximum or the minimum of a function, the first step is to find the derivative so that we get the critical numbers. The converse of that is that if you know that there is a maximum or a minimum at a certain value of x, that means that value of x is a critical number, right? So since we were told that at x equals 16, the function attains a minimum, then x equals 16 must be a critical number. And Marin is right. Being a critical number means when I plug in 16 into the derivative, it must be equal to 0, right? So let's note that what is f, what would f prime of x be? So f prime of x would be, I take the derivative of, or actually this is y prime, right? So we know how y looks like when we take the derivative. It would be what? Recall that y is equal to ax to the negative 1/2 plus bx to the 1/2, right? Coming from the problem, so if I take the derivative of that, I'll have negative 1/2 ax to the negative 3/2 plus 1/2 bx to the negative 1/2, right? Let me just rewrite this down. This would be y prime equals negative a over 2 square root of x quantity cubed, right? Plus b over 2 square root of x. And then if I plug in 16 here, we should get 0, right? Plug in x equals 16 and y prime equals 0. So we get negative a over 2 square root of 16 cubed plus b over 2 times root 16. So that will be 0 equals negative a 2 times, what is square root of 16? It's 4. 4 cubed is 64 plus b over 8. And so this will be 0 equals negative a over 128 plus b over 8. And then we can multiply both sides by 128 just to get rid of the denominator of the fractions. So I'll have 0 equals negative a plus, what will this be? 16b, right? So this would be my equation double star. Okay, so we now have two equations. So now we need to solve that system of equation. Remember from star, we have this equation. And from double star, we have this equation. And then we can solve them any of the methods you know for solving equations, systems of linear equations. I can simply add the two equations up. So I'll get 32 equals a plus negative a, that's 0. And then 16b plus 16b is 32b. That means b is equal to 1. Then I can use b equals 1 in equation star. That gives us 32 equals a plus 16 times 1. That means what? A is equal to 32 minus 16, and that is 16. So the answer here is a equals 16 and b equals 1. Okay. Okay, is that good? Okay, maybe another one. Okay. So Robert, what did you use then if you didn't use calculus there? I guess the only calculus part there is the fact that we need to interpret x equals 16 giving a minimum, right? But a cheap solution to this is to plug in values and check if any of the choices satisfy that the fact that the value at 16 must be equal to 8. Yeah, it's about knowing the concept. It's a bit so you need to do it step by step. and apply all those concepts. Let's see another one. Okay. Let's call this problem, hold on, problem I. So in short, we need to find for this next problem, f inverse prime of 4 pi given f of x equals 8x plus 4 cosine x. Okay, so how do we solve this? For this one, we need to recall a certain formula from Cal 1. Recall that f inverse prime evaluated at a number b is equal to 1 over f prime of a, where f of a is equal to b. Okay, so now we need two things here. We need to know what f prime is, and we need to know what the number a is, because from the problem, from the given info in the problem, comparing this formula with what we are looking for, b is equal to 4 pi. Clear? Right? So we know b is equal to 4 pi. Then the right-hand side of this formula requires us the knowledge of a and f prime. Let's start with the easier one, f prime. So note, we know f from the problem, so we solve for f prime. It's 8 minus 4 sine x. So that's fine. Then all that is left to be determined is the value of a. Also, note that we want to find a, or a number a, such that f of a is equal to b. Right? So f of a is equal to b, so I plug in a into f, so I get 8a plus 4 cosine a, right? Equals b, but from the problem we knew that b is equal to 4 pi. The question here is what should be the value of a here? Well, the thing about this is what? It's not an easy equation to solve, but I want to work this out a little bit. For instance, yeah, sure.
Can you explain how you got 8a plus 4 cosine a equals 4 pi again?
Okay, yeah. Because here I need to plug in a into the right-hand side of the equation, so I need to solve for a. But what's the requirement for a? The formula says f of a must be equal to b. So f of a, I plug in the number a into the function f.
Oh, okay.
That's how I get 8a.
You know that b is 4 pi, right?
Right, coming from the problem, b is 4 pi there. So now here's the difficulty. I need to solve this nonlinear equation. But I can simplify this a bit because what? How can I simplify this?
You could take out the 4.
Okay, yeah. I can divide both sides by 4, so I'll get 2a plus cosine a equals y. Okay, hold on. Why is there echo there? But anyway, okay. Now, there's still a difficulty here because there is a cosine here. And I guess the thing here is that I want to eliminate that cosine, and hopefully I'll be lucky to have a quick solution here. This is a Cal 1 or Cal 2 problem, so I don't expect a very complicated solution for this. But I can just try to look for special values for a. For instance, remember that the odd multiples of pi over 2 will have cosine equal to 0. And I hope there's an odd multiple of pi over 2 such that 2a is equal to pi, right? And true enough, Marin is correct. A nice candidate for a would be pi over 2. So note that I can test if pi over 2 would be fine. So 2 times pi over 2 plus cosine of pi over 2 is equal to pi plus 0 is equal to pi. And I'm lucky to get this one, right? We were just lucky that the problem has this quick solution. Again, my thinking here is that at this particular point, because this is Cal 1 or Cal 2, I'm not supposed to to employ a very sophisticated way of solving this nonlinear equation. They are taught in higher math classes. But the thing here is that, can I have a special value for a that will make cosine simple? And the prime candidates for that would be the odd multiples of pi over 2. Because for pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, 9 pi over 2, and so on, cosine will be equal to 0. So if I'm thinking that my candidate for a would be odd multiples of pi over 2, then cosine will simply vanish. So the problem now boils down to finding an odd multiple of pi over 2 such that 2a is equal to pi. And as Marin suggested, a nice candidate would be pi over 2, and it checks out that pi over 2 is the correct choice for a. Okay? And so I can apply the formula that we listed here before. So f inverse prime of 4 pi would be equal to 1 over f prime evaluated at a. We knew that our the choice for a is pi over 2, right? And then plug that into f prime, which we solved earlier. This is 1 over 8 minus 4 sine of pi over 2. Sine of pi over 2 is 1, so this would be 1/4. All right. So I guess the hard part here is solving this nonlinear equation. There are fancy techniques for higher math courses, but this is Cal 2, so you are not expected to use those sophisticated techniques. So it's just by inspection, my prime candidates, so that cosine will vanish would be pi over 2, 3 pi over 2, 7 pi over 2, 9 pi over 2, and of them, only pi over 2 will satisfy the equation. All right. Maybe I have one more time for a review topic before I go to the mean value theorem, because I want to have some time to discuss some examples for MVT. Okay. Unfortunately, Faiza, I cannot open the file you sent in the chat. Can you send it via a screenshot or something? Yeah, let me see. Okay, I know Katie has sent a couple more questions here, but I don't think we'll have time to cover all of them. So I can just send you email later about your questions there, or I can include them in the annotated worksheet later. I'll just include a detailed solution for them. So I hope that's fine. Okay, yeah, or that's a better idea. Go to CASA tutoring for those problems left. Yeah, let me see. Question from Kayla. Okay, I can quickly answer Kayla's question. So let's call this problem J. The integral of e to the x over 1 plus 16 e to the 2x dx, right? So I remember telling you last time that the prime candidates for the u substitution whenever you have a fraction is something coming from the denominator, right? But that won't be the case here, because if you let u to be the denominator, then du would be 32 e to the 2x dx. And you cannot get an e to the 2x in the numerator. So that's out of the question. Letting u to be the denominator is out of the question. The numerator cannot also serve as your, or can serve as your e to the as your u, but that will require a formula involving inverse trig functions. So I guess it would be useful to recall. Oh, I guess we solved a similar problem to this last time. So you can go back to the worksheet or watch the recording for more details. But here, you can compare this with the formula of yielding, or for the formula of the integral yielding inverse tangent function. So in particular, that's du over a squared plus u squared is equal to 1 over a arctan of u over a plus the arbitrary constant c, which is this can be your second step. Basically, if letting u to be the denominator won't work, then try comparing it with the formula for integrals that yields inverse trig functions. And if you notice here, a could be a squared, that's fine. And then u squared can be 16 e to the 2x. Then let's hope that that substitution will bring us somewhere. So here, I can take a squared equals 1. So that means a is equal to 1. And let's try u squared equal to 16 e to the 2x, right? I'll test this if this formula will work or this substitution will work, right? And again, the requirement for this substitution to work is if you get the appropriate du. Now, if u squared is equal to 16 e to the 2x, then if you take the square root of both sides, you get u equals 4 e to the x, right? And if that is u, then du would be what? 4 e to the x dx. Do we get that somewhere in a given integral? Yes. I have an e to the x there, and then I have a dx there. I can remedy the missing constant factor by dividing both sides by 4. So this tells me that e to the x dx can be replaced by du over 4. Right? So the given integral, e to the x over 1 plus 16 e to the 2x dx, can be rewritten as, again, e to the x dx will be replaced by du over 4 times 1 plus 16 e to the 2x, which remains, can be written as 1 plus u squared. And this is basically 1/4 integral of du over 1 plus u squared. And let me continue here in the next page. Okay. And so here I'll have 1/4 times arctan of u plus the arbitrary constant c. Yes, you're right. U is equal to 4 e to the x. Robert, yeah, you're correct. And then finally here, I can revert to the original variable x. So arctan 4 e to the x plus the arbitrary constant c. So there's my substitution there. And again, I got that idea of letting u equals 4 e to the x by comparing the given integral with the formula for the integral that yields arctangent. Okay, so I hope that makes sense. All right, so yeah, for the rest of the meeting, I just want to go quickly over some problems involving the mean value theorem. If we find them easy and we have time, I can probably go back to some of the questions in the chat. I guess there are 2 or 3 more questions, but unfortunately, we're running out of time, and I want to cover some examples from for the mean value theorem. You guys can also join my CASA tutorials. That's 6 to 7 p.m. every Tuesday and Thursday. I'll be there in CASA. Or if you're not available during those times, you can drop by CASA most of the work week, and there are TAs that can help you there, right? So in case I am not able to answer your questions here. But I appreciate that you guys are sending in your questions. So it's just that really we have many questions today with just a little bit of time. All right. So quickly, let's go over section 7.1. This is about the mean value theorem for integrals. Basically, okay, before going there, Brian has a quick follow-up. What happened to the a dividing u? Here in this, yeah, you're right. That should be present there, but the thing here is a is equal to 1. So that's why I omitted that. But you could have written u over 1, but that is simply equal to u, right? So we're lucky that a is equal to 1, so the solution looks much simpler. but otherwise you would have a u over a. Okay. All right, so mean value theorem for integrals. So what does the mean value theorem for integrals say? It says that if you have a continuous function on the closed interval AB. By the way, guys, I'm a big fan of using mathematical symbols for shorthand notations. So this means f, the function f, is continuous. That's what the curly C is for. That means your function is continuous on the closed interval AB. So if that is true, if your function is continuous on the closed interval AB, then there exists this weird looking E, means there exists. Though these are formal math notations, I just didn't invent them, so you can also see them in some books. Then there exists a number C on the open interval AB such that f of C is equal to 1 over b minus a, integral from a to b of f of x dx. There's a special name for the right-hand side of this equation. This right-hand side is also referred to as the average value of your function f. So you can call this the average value of f on the interval AB, right? So basically what the mean value theorem tells us that if your function is continuous on the closed interval AB, then you can find a number C on that interval such that f attains its average value, right? So a couple of things here. The formula for the average value, you should remember that that's the integral times 1 over the length of the interval, right? And then the existence of the number C. Unfortunately, the mean value theorem doesn't give us any more idea about the number C. It only tells us that there exists a number C. It doesn't tell us how many C's are there or what is the value of C. So we need to calculate them manually, right? So let's look at some quick problems about this. So problem A. For this, we want to find for I think questions 1 to 3. I want to find the average value of the following functions on the given intervals and find a point on the given interval at which the function takes on the average value. So let's start with problem 1. Let's probably start with finding the average values. So the average value again is 1 over the length of the interval times the integral over the interval of f of x dx, right? The interval is 0 to pi, so its length is pi. So I'll have 1 over pi times integral from 0 to pi of 2 cosine x dx, right? And then here, this would be, I'll evaluate the integral. So this would be 1 over pi times 2 sine x evaluated from 0 to pi. And this would be 1 over pi times 0, right? Because sine pi is 0, sine 0 is 0. So basically the average value is 0. Okay? And that takes care half of the problem because yeah, we already computed the average value. The follow-up question is find the number C at which this average value is attained. So we want to solve for a number C, but that number C will just be between 0 and pi such that f of C equals the average value, right? But f of C, I'll plug in C into f, so I'll have 2 cosine C equals the average value, but the average value is 0, okay? Then divide both sides by 2 to get that. And what is the number, what are the angles C from 0 to pi that will give us cosine equals 0? I guess there's only one, and that's pi over 2. Okay, so in summary, what we found here is that the average value of the function is 0, and it is attained when C is equal to pi over 2. Okay.
Is that function, the second row where it says 1 over pi 2, what is in that parentheses? Because I can't read it.
You mean here?
Yes, that. Sorry.
Yeah, that is 2 sine x.
Thank you.
Sure. So that's just the antiderivative of 2 cosine x. All right, let's try another one. Nice question, Kevin. Yeah, cosine of 3 pi over 2 is also equal to 0. But again, the mean value theorem guarantees the existence of a c between 0 and pi only. So we are only living on the interval 0 to pi. So any other number c that is outside the interval should be discarded. So though 3 pi over 2 it will satisfy the equation f of c equals f av a, but it's outside a given interval, so we need to discard that. Good. Let's try problem 2. F of x is equal to absolute value of x over the interval -4 to 4. Again, let's start by looking for the average value, which is basically 1 over the length of the interval. So here the length of the interval is 4 minus -4. Integral from -4 to 4 of f dx. Good. Then this would be 1 over 8. Integral from -4 to 4, absolute value of x dx. Okay. And here I'll use the symmetry of the absolute value function for me to be able to evaluate this more quickly. Well, the long solution is to split the integral up. First one is the integral from -4 to 0, and the other one the integral from 0 to 4, right? Because on those two intervals, the value of absolute value of x differ. But another quick solution to this is to take note that, okay, absolute value function or its graph looks like this, if you still remember. And what's the good thing about the absolute value function? It is symmetric with respect to x equals 0, right? So that means this area, the area from 0 to 4, is equal to the area from -4 to 0, right? So that means instead of integrating from -4 to 4, which will require splitting the integral up into 2 pieces, I can use this trick. So I'll copy the 1/8 coming from the problem. But now I'll just evaluate the integral from 0 to 4 of absolute value of x dx. That will just be this region, finding the area of that region. I'll tell you why I prefer doing that later. But after I got the integral from 0 to 4, I simply need to multiply it by 2, right? Because this area is the same as this area. The area of the yellow is the same as the area of the red region. Do you agree with that, guys? So this is a helpful shortcut whenever you are sure that a certain function is symmetric with respect to some number. Okay. Now this would be 1/4 integral from 0 to 4 on the integral on the interval 0 to 4. The absolute value is simply itself, right? The absolute value for number x is simply itself from 0 to 4. And then evaluate this integral will give me 1/4 x squared over 2 evaluated from 0 to 4. And that would be what? If I evaluate that, this would be 1/8 times 4 squared minus 0. So that's going to be 1/8 times 16. That would be equal to 2. Okay. So does that make sense? This is a very helpful one because if you will split the integral up into 2 pieces, that will take a lot of time. But nevertheless, you'll get the same answer, right? I just prefer the shorter one. In case you want to see the longer solution, you can check my the annotated worksheet for my other lab, for lab 02. You can see it in my website as well. Because I don't think we have time to go over that. But yeah, that's a nice solution here, a nice shortcut. And lastly, now we look for C on the interval -4 to 4, such that f of c equals f av a, right? Or the average value. Now, f of c, we plug in c into the function. Remember, our function f here is the absolute value function. And the average value is equal to 2. So now, do you guys remember how to solve this equation? Or what are the numbers c such that the absolute value of c is equal to 2? Are you still there, guys?
2 or 2? Or 2 or -2 would work.
Exactly. So c equals plus or minus 2. So this is a good example that there can be more than one c on the interval, on the given interval that satisfies the mean value theorem. It's just that the mean value theorem doesn't tell us how many are there or what are those, but essentially we know that there exists something, and it's just for us to compute them manually. Okay. So okay, let's see the other problems here. Oh, just take note that both 2 and -2 are on the given intervals, so we don't need to discard any of them. Problem number 3 is quite similar. The only thing here is that you have parameters m, b, and a. It's just that you should treat m, b, and a to be constants, but there's no big problem about that. I'll skip number 3 for now. Maybe I can include it in the annotated notes, or we can go over it on Wednesday. I just want to tackle one of the problems from part B today. Sure, before going there, I can walk you through again how I got C equals, how do I find absolute value of C? Kevin, are you referring to how did I arrive at this?
Oh, like the plus minus 2.
The plus or minus 2, right. Basically here you're looking for what are the numbers C whose absolute value is equal to 2. So basically, if you take the absolute value of 2, it's equal to 2. So C equals 2 is fine. Then if you take the absolute value of -2, the answer is also 2. So,
okay.
So basically, you're looking for what are the numbers when put inside the absolute value symbol will give me 2. And there are only 2 answers, plus or minus 2, right?
Thank you.
Sure. So maybe I will end with, say, problem B for today. So here we are given that the average value of the function f over the interval 1 to 4 is 5, and I need to find the integral of 6f of x dx from 1 to 4. Again, for word problems, we need to interpret what are the given info and put them in the context of what is being asked in the problem. Just bear in mind this is what we are looking for. But let's start by picking out what would be the information or what are the useful information from the problem. Well, we were told the average value of f on the given interval is 5. So we know that here f ave is equal to 5. But we know the formula for the average value, right? It's 1 over the length of the interval times the integral over that interval. Okay, so here we know that 5 is equal to 1/3 of the integral from 1 to 4 f of x dx. Then from here, I can multiply both sides by 3 to arrive at the conclusion that the integral of f of x dx from 1 to 4 is equal to 15. But remember, I'm looking for the integral from 1 to 4 of 6 f of x dx. I can use properties of integrals here. I can take the 6 out, right? And look at this. I have the integral from 1 to 4 of f of x dx, which I already surmised from the given information from the problem. So this, the value we're looking for is 6 times 15, which is equal to 80. All right. Does that make sense, guys? Okay. Double check that, Mary. I think it's 80. Okay, so now it's already time. We're just right on time. But I have a question for you guys. There are still some problems here in this worksheet, specifically problems 3, 5, 6, and 7. we have two options. Either I can upload the solutions to these problems today and start with sections 7.2 and 7.3 on Wednesday, or I can upload the worksheet as is as it is now and start Wednesday with or Wednesday's meeting with the problems that we left out today. So which one do you prefer? Should we start with these problems that we left out on Wednesday, or should I just upload the solutions? Okay, that sounds good. So if you guys agree, then we start on Wednesday on some of the problems. Probably there are 3 problems left. Maybe I'll do 2 of them and then leave 1 for you guys. But again, any problem in worksheet number 2, or yeah, just rest assured that you will have a complete worksheet number 2 uploaded sometime this week. So yeah, let's start on Wednesday with some of the problems we left out. And then we'll go into a worksheet 3, which will cover problems from section 7.2 and 7.3. To answer Fatuma's question, I don't have a personally written extra practice problems for 7.1 to 7.2, but what you can do is check the textbook. So if you log in into your CASA account, I guess you still have access to the textbook, the calculus textbook on top. You can click on that, and then there are a lot of practice problems for section 7.1 to 7.2. Actually, that's where I got these problems from the textbook. So yeah, you can access the calculus textbook via your CASA pages. All right. So yeah, that's a good source of practice problems because they also have the final answers for the odd questions. So you can work on them and then check your answers for the odd questions. If something is not making sense or you have some difficulties answering them, just let me know. And I can either answer them on the lab meeting if I think that's a very interesting question that everyone deserves to hear the solution of, or I can send it to you via email, or you can go to me on my CASA tutoring hours. Okay. Again, the meeting recording will be available either on my webpage or on MS Teams, so you can rewatch this. Annotated worksheet will be available sometime this afternoon. So I just have a meeting coming up at 1, so I can't work on it, or I cannot upload it right away, but it will be uploaded later in the day. So that's it for now. Okay, you guys have a great day ahead, and let's see each other on Wednesday again. Thank you for coming, and yeah, bye.